Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today in mathematics, we will continue our work on circle parts. Remember that in our last lesson, we talked about the lines that can be found in and around a circle. Today we'll focus on the shapes that are formed by those lines. But before we go into that, I know you're excited and you can't wait. But we need to review the correction to the previous assignment. In the last lesson, you were asked to name the following lines. So LN is a straight line that joins L to N, and that is a chord. Remember that the chord is a straight line that touches 2 points inside the circle. The next one is MQ. MQ, the only line that joins MQ is a curve, and that is an arc. Remember that an arc is a part of the circumference. Circumference has to be closed. Anything less than the circumference is an arc. PQ, the only line that joins P and Q is also an arc. Then OM. O is the center of the circle and M is on the circumference. The straight line that joins them is OM, and that is radius. Remember that the radius is a line from the center that touches the circumference. A straight line, mind you. Now MP. That MP is coming from one end, touching the circumference here, and passing through the center. And of course, a straight line that touches 2 points and passes through the center is a diameter. Finally, LMQ. Let me trace that for you. LMQ, PN, back to L. That closes everything. And that makes that the circumference of the circle. Now, I believe this was easy peasy for you, and I assume that you got it all. So for that, I'll give you a big chair. Now, moving on to today's lesson. What's our lesson objective? By the end of this lesson, you should be able to identify shapes that are formed by the circle lines. Remember, I said that today we'll be focusing on the shapes that are formed by the circle lines. Next, you should be able to differentiate between segments and sectors. I mean, what are segments? What are sectors? You just hold on. You don't need to rush yourself. We'll soon get there. Finally, you should be able to identify and name special sectors and segments. Sectors, segments. You probably come around a lot about these words in your storybooks or in newspapers, but they mean a whole different thing in mathematics, as you will see, my friend. Let's just get right into it. In our last lesson, we discussed circle lines. Circle lines usually divide circle into small chunks. You know, drawing a line on a circle is like putting a knife on it. You are bound to divide it into two. So in this lesson, we'll study circle shapes like I have said. Now, this is a circle, and this line AB is a chord. Remember, a chord touches 2 points. So this chord starts from A and goes to B. Now, this chord automatically divides the whole circle into 2 parts. I mean, there's this part below, and there is this part on top. I mean, I remember when I was young, my brother and I, during the month of Ramadan, when we want to fast, we want to share an orange, and my brother would just cut the top for me. I'm sure your brother has done something like that for you as well. Okay, so something like this. They don't want it to be equal, so they give you the smaller part on top, and they take the bigger part below. So that line that divides this shape into 2 equal parts, into 2 parts, not equal, is called the chord. Now, but what are the parts called? This part is called a segment, and this other part is called a segment as well. Say segment, segment. Now note this spelling, although that should be easy for you to spell. Now, this obviously is bigger than this. This is a bigger segment than this one. So we call this one the major segment. Major, you know, means big. And the other one is called the minor segment. It should be easy for you to remember. So segment is like that orange. The bigger one is the major segment, and the smaller one is the minor segment. Take note of that as we move on. Now, a segment is a closed shape. Okay, this is what we call a segment. Okay, let's talk about segment. We are actually referring to this whole thing. the chord, and the arc. A segment is a closed shape. It must be closed. Okay? It is bounded by a chord and an arc. So, for example, this is a segment. But if it is not closed, like this one, it's not a segment. It has to be closed. Okay, so a segment is bounded by a chord, this line, and an arc, this one. Okay, so let's move on. That's orange that I was talking about. Okay, so this is a segment. So just you have an arc, then you have a chord, a straight line. Okay, so you can see that segments are actually things that are easy to find around you. So let's move on. Now, if the chord is a diameter, this chord, if it becomes a diameter, the only way to become a diameter is if it passes through the center, then the segments will now be equal. Like I always tell my brother, no, you can't give me the small one. I mean, we've been fasting since morning. Cut it equally. I must get the same size that you are going to get. So now, if we make that chord into a diameter, then now the segments are equal. And each part is now called a semicircle. Okay, you see, the semicircle is a special segment. Okay, that is half of a circle. The semicircle again is a segment, but it's a special segment that makes up half of the circle. So in this case, there's no major segment, there's no minor segment. It is 50-50, no cheating, like you say. So semicircle, semicircle, they are equal. Each part is called a semicircle. No major segment, no minor segment. Now, a semicircle, like I have said earlier, is half of a circle. So this is a semicircle. So don't forget that the diameter can come in different form. It can go diagonally like this. It can come vertically. It can come. So all these are semicircles. They are equal. As long as you have a diameter in between, the diameter will divide the circle into two equal parts. And these parts are called semicircle. Semicircle means half circle. Okay. A semicircle is bounded by a diameter, and this is the diameter. Passes through the center. And an arc. This is the arc. That's what a semicircle is. A semicircle is bounded by a diameter and an arc. And these are semicircles in real life. You see this beautiful fancy window is semicircular in shape. Architects always, have fun doing something like this. Your protractor that we used to measure angle the other time is in fact a semicircle, because if you put two protractors together, you will get a full circle. And don't forget that the semicircle is 180 degrees. The speedometer on your daddy's car, your mommy's car, check the front, you will see the speedometer. It tells the speed of the car. It's in the semicircular shape. The odometer is also in the semicircular shape. The speedometer reads how fast the car is going, and the odometer tells the mileage on the car. And of course, the rainbow. You've seen the rainbow before? After the rain, the rainbow just comes out in the horizon. It's usually semicircular in shape. All right, so let's move on. So what's this diagram telling us? An angle in a circle divides the circle into two. Remember when we're studying angles, usually I use the circle to demonstrate angle to you. So this is an angle in a circle. Remember when we're doing angle between the numbers on the clock face? Yes. Then there is the big angle and there is the small angle. And of course, this is the small angle. When they find the angle between the larger ends of the clock, so you always use this angle. Then when they say find the larger angle, you will always take this big angle. Now this angle inside the circle divides the circle into two, of course. There is the small part here and there is the big part. What are these parts called? Each part is called a sector. Okay, so now this is where you need to make the differentiation. Segment is a straight line that will divide that. But for sector, it's an angle passing through the center that will divide that. Okay, so each part is called a sector. So let me just erase this line so that you can see what I'm about to put there for you. Okay, so now this small sector, what do you think is going to be called? Did I hear you say smaller sector? No, it's not smaller sector. It's actually minor sector, much like the minor segment, minor sector. And the bigger one, of course, automatically will be called the major sector. Now, moving on. So here is another sector. So anytime you have an angle, automatically you have a sector. The smaller one, minor sector. The bigger one, major sector. As you can see, minor sector, major sector. And the sector is also a closed shape, you know. It has to be closed. It must be bounded by an arc and two radii. Remember that I said that radii is the plural of radius. Bounded by an arc, a curve like this, and then two radii, two straight lines. What you call a sector, much like that tiny piece of tangerine that you remove from the whole tangerine. Yeah, that's a sector. When you get to secondary school and you're going to be taught about volume of spheres, you'll be using the tangerine as an example. But for now, let's just focus on the plane part of it. So that is the sector. It is formed by an arc and two radii. One radius here and one radius here. And then there is this pizza, and that gives you a perfect example of a sector in real life. Imagine you have to share a pizza with someone and it gives you the minor sector. You won't like it, won't you? You would want to have the diameter, the semicircle. Okay, but so this represents the minor sector and the bigger one represents the major sector. And this looks very, very yummy. You want to eat some? You got to go buy some. Let's move on. If the angle that we're talking about, the angle that forms the sector, if that angle is a right angle, then we don't call it a normal sector anymore. It's a special sector, which we call a quadrant. Say the word quadrant. Quadrant. Now, a quadrant is like this. This is the angle. And then there is the box in the corner. So it is a sector, but it is a special sector, which we call a quadrant. Don't forget that we have a special segment which we call a semicircle. Now we have a special sector which we call a quadrant. This is another quadrant. See, it doesn't really have to be in the 3 o'clock form like this or 9 o'clock form. As long as you see two radii and there is a box in the corner, automatically you have a quadrant. Because now this one will be another box and this one will be another box, another box. And you have your 4 quadrants. So, but how many quadrants do you think are in a circle? I think I just gave you the answer to that. How many did you say? Yeah, there will be 4 quadrants. Because there's one here, there's one here, there's another quadrant, there's another quadrant. They are all forming 90 degrees. So again, when the two radii are meeting at 90 degrees, you have a special sector which is called a quadrant. A quadrant is 1/4 of a circle. Right? It's 1 out of 4 parts, like I've shown you earlier. So you can see 1 out of 4 parts. So if I shade this, that's 1 out of 4. You know, you use this kind of diagrams when you're doing fractions. 1/4 of a circle. So a quadrant is just 1/4. The remaining will be 3/4. So how many quadrants in the circle? 4 quadrants. Good. A quadrant is bounded by 2 perpendicular radii. Big grammar. But I've taught you what perpendicular means. It means 2 lines that meet at 90 degrees. So when we say 2 perpendicular radii, that means radii that meet at 90 degrees. A quadrant is bounded by 2 perpendicular radii. That is, the fence of a quadrant is 2 radii that are perpendicular and an arc. That's what it means. The fence, imagine this is somebody's house, and the fence of the house will be one line that is perpendicular to another one, and then closed by an arc. That is what you call a quadrant, my friend. And this is an example of a quadrant in real life. I suppose this person just put popcorn, granules, and all other whatnots in a tin or a can and partitioned it into 4. This will be a quadrant. This will be a quadrant. This will be a quadrant, and this will be a quadrant. Okay, so these are examples of quadrants in real life. So let's do some activity. The yellow part is called what? Easy, right? Did I hear you well? Did you say sector? Of course it's a sector because you have an angle, okay? So it is a sector. The next one says the part shaded blue. Yeah, this part. What do we call the part shaded blue? Did I hear you say chord? It's not a chord. Sector? Not a sector. It's actually a segment, because a segment is a part that is bounded by a chord and an arc, and that is the blue part. It is a segment. In fact, it is a minor segment, because the whole of this part now will be the major segment. The part shaded red is called what? Note the line dividing them and where it is passing. It is passing through the center of the line. And of course, you know that this is half of a circle, which we call, good job you, it is the semicircle. The red part is a semicircle, and it's also equal to the white part, which is another semicircle. The white part is called what? There is something that should tell you the answer to that on the diagram. It is colored blue. The white part is what? There is a right angle, and there is a perpendicular radii, and there is an arc, and we call that the quadrant. Now, finally this one. Study these questions critically. Which of these is not true? All these statements are true, except one of them. When you are given this kind of question, you have to think, which one is true? Which one is true? Take all the ones that are true. The one that is not true, identify it as your answer. The first statement says, a quadrant is a sector. Second one says, a semicircle is a segment. Third one says, a sector is a segment. And fourth one says, a quadrant is half a semicircle. One of them, just one of them, is not correct. We found the answer. Well, let's take a look. A quadrant is a sector because it is bounded by an angle and an arc. And all sectors are bounded by angles and an arc. So a quadrant is a special sector. A semicircle is also a segment because a semicircle is, a chord and then an arc. And all segments are chords and arc. It's just that the semicircle, the chord is a diameter that passes through the center of the circle. Well, a sector is a segment? No. A sector is not a segment because sectors are formed by angle while segments are formed by chords. The last one, a quadrant is half a semicircle. Well, that statement is true. And because if I draw, this is a circle. Let's just take this one as a circle. And I have a quadrant here. Then this will be another quadrant. And the whole thing is a semicircle. So a quadrant is half of that. So this is correct. The correct answer is, the one that is not correct is, a sector is a segment. Good job, you children. Now it's time for your homework. I want you to copy these questions in 1 minute and fill in the blank spaces. I'll be back to sign off in 1 minute. All right, eyes on me. Now we've come to the end of the mathematics lesson. We're done discussing plane shapes, and I believe that you enjoyed yourself. Test your knowledge by taking the online assessments. I will now hand you over to Uncle Popo for the general studies lesson. Till I come your way, next lesson, Remain wonderful mathematicians.